Okay, so question number 7 is to draw the Lewis structure for CH3NO2 and include all lone pairs and electrons. Okay, so when writing out the Lewis structure, we first need to calculate the total number of valence electrons. So carbon has 4 valence electrons, hydrogen has 1, and since we have 3 hydrogen atoms, we multiply this by 3. Nitrogen has 5 valence electrons, and oxygen has 6. And since there are 2 oxygen atoms, we'd multiply this by 2. So this gives us a total of 24 valence electrons. Okay, so now let's try to draw out a Lewis structure for this compound. We would have carbon bonded with 3 hydrogens, and then also bonded to the nitrogen, like so. So let's count out how many electrons I have in this structure. We would have 10 out of the 24 electrons. So let's see what happens if I draw in all of the lone pairs on my oxygens. So this gives us 22 out of the 24. So I'm going to also show that since nitrogen doesn't have a full octet yet, I'll bring down a pair of electrons to form a double bond. And now we have 24 electrons in this structure. Okay, so we're almost done. We just need to calculate the formal charge of all of our ions. And one of the rules of thumb is to have the most electronegative atom carry a negative charge if there is one. Okay, so let's calculate the formal charges. So the equation for formal charge is the number of valence electrons minus the number of non-bonding electrons minus the number of bonding electrons divided by 2. So let's calculate the formal charge of one of the hydrogens. Hydrogen has 1 valence electron, 0 non-bonding electrons, and all of the hydrogens just have a single bond. So each bond contains 2 bonding electrons that we divide by 2, and we get a formal charge of 0. So for the carbon has 4 valence electrons, 0 non-bonding electrons, and there are 4 bonds to the carbon, so we have 8 bonding electrons divided by 2. So we also have a formal charge of 0. So now let's calculate the formal charge of nitrogen. Nitrogen has 5 valence electrons, and there are no lone pairs on the nitrogen, so we have 0 non-bonding electrons. And there are 4 bonds to our nitrogen, so we have 8 bonding electrons divided by 2. So the nitrogen will carry a positive 1 charge. So we can show that on our structure. A bit too close. Like so. And now we can continue on to calculate the formal charges of both of our oxygens. So for the double bonded oxygen, there are 6 valence electrons, 4 non-bonding electrons, and there are 2 bonds to the oxygen, so we have 8 bonding electrons divided by 2. 4 bonding electrons divided by 2. So we'd have a formal charge of 0. And lastly, we have our single bonded oxygen. There are 6 valence electrons, 6 non-bonding electrons, and just a single bond, so we have 2 bonding electrons divided by 2. So our oxygen will carry the negative charge, which is preferred since oxygen is the most electronegative in this atom. So then when we are to calculate the total charge of the compound, it's just going to be the sum of all of the formal charges. So we have -1 from the oxygen, and we have +1 from the nitrogen, making an overall neutral compound. Okay, so this is the correct Lewis structure for CH3NO2. And the junior tutor said that for step 1, arrange the symbols in this way that the electronegative element is in the center and other elements surrounding it. Step 2, give each of the elements their appropriate number of electrons, dots. Hydrogen has 1, carbon has 4, nitrogen has 5, oxygen has 6. And they did the math and found 24 valence electrons. Step 3 was to draw the Lewis structure. Okay, so they showed the positive charge on the nitrogen and the negative charge on the single bonded oxygen. So this solution is correct.